Just Grant Phillips here. Come to show you my video on my cat and mouse game that I designed and built for SER201 embedded systems design. So yeah, hope you enjoy the video. When we started, I'm connected to the serial test program to simulate an opponent. So I'll press reset. Introduction screen, then we're into calibration straight away. So we're going over, I'll just go to 0, 0 on the board, you can't see, but I'll press the oval button. And then it says to go to 100, 100, top right. Press oval again. Now we'll select R for cat. You're the cat. Calibration complete, runs through a quick run around of the board to show us the boundaries. Now press oval when ready. Waiting for opponent, press start on the computer, and we're off. Now you can see the coordinates on the left there, X and Y. In the middle we've got time counting down, and that we're the cat on the right. Now, we're saying we're the winner because if you see our coordinates there, we're within 4 centimeters of the mouse, which didn't move on the test program, which was at 50-50 in the center of the screen. Demo of the tilt controller with this magical block of cheese that just so happens to have an accelerometer screwed to the bottom of it. 3D printed block of Swiss cheese. Now as you see, when I tilt it to the left, it moves to the left. When I tilt it to the right, it moves to the right. When I tilt it up, it goes up, the laser. When I tilt it down, the laser goes down. And when I do this kind of movement, it goes all over the shop. So it's controlling angular displacement rather than velocity or acceleration or anything like that. I've just got it straight on angular displacement. So as I tilt it up, the laser tilts up, reflects the tilt of the cheese. Fairly jitter-free. I've got a little bit of a buffer in there, a bit of hysteresis, just so it doesn't update too quickly. And I've got it to microseconds rather than servo angle for the PWM control in the Arduino library. So let's go through the calibration routine. I'll switch it on. Now it's saying on the display, which you saw before, go to 0, 0, which is the bottom left corner here. So I'll use the controller to get the laser to the bottom left corner. When I'm about there, I'll press the oval button as it's telling me to do. Okay, now the display is saying go to 100, 100, which is the top right corner. So I'll press the button again. Now it's saying select player, cat or mouse. So I'll press the left button this time for mouse. It's saying you're the mouse. Calibration complete. It'll run around the board, showing us where it thinks the boundaries are. A little bit of skew there. And now it's asking us to press the oval button when ready. And there we go. Now it's displaying our coordinates. Thought I'd better run another calibration routine with the laser in a different spot this time. Last one, the laser was about here, probably 70 centimeters away from the board. This time we'll do it at 120 centimeters. And yeah, just run through it. So use the controller to go down to 0, 0. Press the oval button up to 100, 100. Press the oval button. Select a character, I'll go right for mouse. There we go, now it's going to run around and show us where it thinks the corners are. Beautiful, not too bad. There we go. The main source of error that we do get is if this isn't quite level, and so the floor in my garage here where I am, the table's not level. I've just had to level the pad a little bit, but the rotor on the shaft on the X-axis motor must be perfectly aligned with the Y-axis to avoid any slope or skew in the coordinate system. And same with the Y-axis motor shaft should be on the X-axis plane, just to ensure that there's no skew that way. Hopefully you can see the laser moving around and the mouse moving around on screen fairly synchronously. Obviously a little bit of lag and a little bit of calibration error in there probably, but generally they're moving together. So let's see what happens. See if you can see. Yes, I think you could. I'm just going to bring the cat down to try and catch the mouse. We've only got 10 seconds, so I might run out of time. But we'll try and catch the mouse. Loser. There we go. You can probably just see it says caught you here. The laser's frozen in place where we were caught. And I'll just take this off so you can see the display. Is that in focus? Oh, we've gone upside down, have we? Anyway, it says loser. So this is an example of me running out of bounds, just to show that it shows up on the serial stream and everything works well. So yeah, here we go. You can see me wandering around a little bit. There's the serial stream. And then in a second I'll just pop out of bounds. And then you can see in the serial stream, there it is. Here's an example of being caught by the cat. So you can see it coming up on the serial stream, wandering around there, going up near the cat. What's happening, mate? Hello? Come and get me. Oh, he's got me. There you go, and you can see it all come up on the serial stream. So everything works well there. Okay, I just wanted to show the construction and that it can run on the power supply that I've given it, which is the battery pack here, which is 2 lots of 6 series AA batteries in parallel. So it's given it 9 volt with plenty of current supply and a power switch here in line. And we've got our Arduino controller and display inside a 3D printed case. I got it from an open source on Thingiverse. I'll put that link up on the screen and in the notes. So I'll take out the power connector and can show the connections on the side there. We've got the USB and power input, and then we've got our cables going in and out for the controller and the laser. And I'll just switch this power switch off and plug it back in to show that it will work. There we go. Shows you starting up. I won't go through the whole sequence. There you go. You've seen the controller already, a 3D printed piece of cheese. And here is the gimbal pan tilt laser. See if I can shine it and destroy my camera. There we go. Okay, so that's just 2 Tower Pro MG90 servos. Commercially available pen and tilt thing. It came with one of those DFR bot kits for another project I was working on. Cool, and I'll open her up and show you inside. Okay, I've opened her up inside. Thought I'd better prove that it's actually got the guts inside it. So there we are. I've just got a LCD, 16x2 LCD with keypad shield sitting over the top of an Arduino Mega clone from eBay. And just with the power, because I said it was 9 volts, the laser and the motors will only take 6 volts. So I used a 7806 linear voltage regulator, which is just sitting here. It's got 9 volts going into it and 6 volts coming out roughly. Throws off a little bit of heat on the back of it there. And I've just soldered that all together in a little bit of Veriboard or strip board or whatever you want to call it. So there it is there. Yeah. And if we're going to have flying leads, we just chuck them on the shield pins here, which have got TX0 and RX0. Throw some flying leads there and connect it up to another system, but because I'm doing it over USB, I didn't really need to do that. Also wanted to mention that the buttons on the enclosure, come in focus, was my first attempt at printing with flexible filament. Pretty happy with it. I mean, they came out fairly messy, but it's generally a pretty hard material. It's like rubber, so it's really hard to print rubber. Lots of stringing, and the support material didn't want to come off. But there you go. There's my first attempt at printing flexible stuff.